Welcome to Calvin's Online Math. In this video, we're going to learn how to do differentiation from first principles. So the formula for this is dy dx is given by the limit as h tends to 0 of change in y over change in x. So change in y over change in x is the same as the gradient function. And the limit as h tends to 0, h is the small change in x when you move along a curve or a line. So the first thing, for us to get change in y over change in x, we need 2 points. So the first point will be given by x and y, but y is x cubed plus 2. So that is the first part. So when you move along the curve, then we reach at another point b, there will be some changes in the value of x. So we represent that change by small h. So we say at b, there will be x plus that small change in x, and then y for part b will be x cubed plus 2. The x we have is x plus h, so we have x plus h cubed, then plus 2. So now that we have 2 points, we can get change in y over change in x. So change in y over change in x will be given by y1 minus y2. So we can take this to be y1. So we have x plus h cubed plus 2. That is our y1 minus y2. y2 is this one right here. X cubed plus 2. And then change in x, we'll have our x1 as x plus h, then minus x2, which will be x. So the next is just to simplify the numerator. So here we have x plus h cubed. So we cannot perform this subtraction because these are complex value. So what we do, we first of all expand this. So you can use binomial expansion to do that. So if you use binomial expansion, then you're going to find that this is x power 3 plus 3x power 2h plus 3x h squared plus h power 3, then plus 2. There was some 2 here, minus x power 3 minus 2. That is the numerator. And then the denominator is x plus h minus x, which is just h. So you can see in the numerator that x power 3 minus x power 3 is 0, and 2 minus 2 is also 0. So it means in the numerator we are left with 3x squared h plus 3x h squared plus h power 3, and the whole of this is over h. So in the numerator h is common, so we can factor it out so that we have h into 3x squared plus 3x h plus h squared all over h. So now h and h can cancel, so that we are left with 3x squared plus 3xh plus h power 2. So that is our change in y over change in x, our gradient function. So remember we said that dy dx is obtained by taking the limit as the small change in x tends to 0 of the gradient function, that is change in y over change in x. So now we have the change in y over change in x, and this one right here. So we have the limit as h tends to 0 of 3x squared plus 3xh plus h squared. So this limit just means that in this particular expression, in this gradient function, any term that has got h in it will eventually be 0. So we can as well say that they're equal to 0 at this point. So amongst the 3 terms that we have in the gradient function, only the first one has no h. So all the ones with h will become 0 because the small change in h will tend to 0 as a approaches b. So Our dy dx therefore is just this term with no h, that is 3x squared. Thank you for watching. Kindly subscribe and see you in the next video.